be transforming the linear function f of x equals x. So this, remember, is called function notation. F of x just means y. F of x really means y. So this is like saying y equals x. So I'm going to write over here y equals x. This is called our linear parent function. It's the most basic linear function. It's just y equals x. We are going to transform f of x equals x or y equals x into different linear functions. So we go to y equals, clear out what's in there. And let's just put y equals x. This is our linear parent function. Everything's going to be transformed from this to another. So if I put the graph in, it has a slope, m equals 1. So it goes up 1 over 1, up 1 over 1. It's a stair step of 1, 1. And our b, our y-intercept is 0. So it goes through the origin. So this is also called a direct variation because it goes through the origin and it's linear. So we are going to look at the different changes that you can make on linear functions. So the first one is changes in direction. So right now it's going like this. If I want to change the direction, instead of going uphill, it's going to go downhill. But that's the only thing I want to change. So the slope is 1 right now. So if I change the direction, the slope will be changed to -1. So open this up, and you're going to put this over. So I'm going to write negative x makes the graph reflect. So whenever you have a negative x, like I'm going to put on here negative x. So I'm going to change the y equals x to y equals negative x. When I graph it, see how it goes downhill? So whenever I have both in there, let's go and put the other one in there also. So we're going to put in both y equals negative x and y equals negative x. Y equals x and y equals negative x. So if you look at my graph, it should have those two. And when you hit graph, these are reflections of each other. So this was y equals x, the linear parent function. And then this is y equals negative x, the reflection of that. So we are going to write f of x equals x. And then we are going to say transforms to, we're going to name this one g of x equals negative x. So that's a reflection. It changed it flipped it. So I'm going to put over to the side, flipped. So reflect or flip, we can use either one of those words. Make sure you're getting this down. Okay, so then we will go over here, and we know that this one is y equals x, or f of x equals x. So we are going to reflect it or flip into y equals negative x. So we know it has, we're going to write over here, y equals negative x. So whenever you graph it, we know it's going to go downhill. It's going to have a slope of negative 1, 1, down 1, over 1, down 1, over 1. And then up 1, left 1. Just do a few dots and then connect it with a ruler to make the line. Okay, so that was changes in direction. Now we'll go on to changes in slope. Changes in direction was uphill or downhill. So if you see one's uphill and one's downhill, then there was a change in direction. If you see the change in slope, what does slope determine? What word goes with slope? Whether it's like this or like this. Uphill, downhill, but what if they're both uphill? Then let's say we have this and we have this. What does slope determine? Steepness, yeah. So let's put on here steepness. So steepness is our word we're looking for when we talk about slope. You can have a really steep slope or a really flat slope. So whenever you do changes in the slope, that means we are going to multiply x by a number, making the graph dilate. So when we're talking about the word dilate, let's say not in math terms, what does dilate mean? Say where do you see this happen? When you're in your eyes, yeah. Whenever you go to the eye doctor, they'll dilate your eyes, and that makes them bigger, right? Your pupil big. What happens whenever you go outside? Let's say you're inside, your pupils are regular size, and then you go outside and it's really, really bright. What happens to your pupils?
Shrinks.
They shrink down. They get smaller. So whenever we talk about dilate, we're talking about how the steepness is changed. Whether it gets bigger or gets smaller. So f of x equals x, and our new equation or function will be g of x equals m times x. So m is going to be the factor of dilation. So I'm going to say factor of dilation. If we have any number between, if m is between, there's an extra e in there, between -1 and 1, That means it's like 1/3, 2/3. What's going to happen whenever you do, let's say we go back to our calculator, right? Y equals X. Let's do a number between -1 and 1. Let's just keep it positive. Let's say it's 1/3. Do you think it's going to make it steeper or flatter? A number between -1 and 1.
Why?
Let's look. Here's our parent function, y equals x. So what happened with y equals 1/3 x?
Got flattered.
Yeah, I got flattered because the red one is our parent function, the blue one is our new one. So red one's our parent function, so it got flatter. So we can call this flatter, but on assignments, you could see it as less steep. I can't even talk. Flatter, or you'll see it as less steep. So when m is a fraction that's less than 1. So then otherwise, it'll be not between -1 and 1. Or let's say greater than 1 and less than -1. Let's say it's like 10. Y equals 10x. So my red one's y equals x. Let's say this is going to be 10x. When we graph it, look how fast that shot up. So this is our linear parent function, y equals x. And then that shot up really fast.
Yeah, super.
So it's steeper. So I'm going to put the word steeper. So on these graphs, we have that this is our linear parent function, y equals x. And we are going to dilate it. And we can dilate it by any number. So I'm going to use y equals 3x as an example. So if it's y equals 3x, what's our y-intercept? 0. And then what's our slope? 3. So I'm going to count 3 over 1. 3 over 1. 3 over 1. Then go down 3 over 1. Down 3 over 1. That's the y equals 3x. So this is steeper. I'm going to get another color and do another one on here. So let's say it's y equals half x. If it's y equals half x, our y-intercept is the origin again. But this time we are going to go up 1 over 2. So count up 1 over 1, 2. Up 1 over 2. Up 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. So you're just counting to get your slope. So then when we connect the dots, so when we have a number between -1 and +1, it makes it flatter or less steep. I'm going to put less steep. Okay, did y'all get that down? Okay, our last one is changes in y-intercept. Whenever you change your y-intercept, let's say you have 0 and then it's -1. What happens to your line? Let's say it's y equals x or whatever this is. If I translate it or change my y-intercept, I'm changing it from here to here. What happened to it? This whole line was just moved down. Nothing else happened. See how it has the same slope, just like parallel lines? But the only thing that changed was it was moved up or down. Okay, so in here we are going to say adding or subtracting to x to/from x makes the graph translate. We're almost done. Let's just finish up real quick. F of x equals x. G of x equals x plus some b. So b can be any number. If b is, you're adding b, you're going to move it up. If you're subtracting b, you're going to move it down. Add, go up. Subtract, go down. So translate is the key word there. You're translating it up, translating it down, but it's going to keep the same slope. So this is our linear parent function y equals x. So let's say our equation is y equals x plus 5. So we did this equation, but plus 5. So that means we're going to go up by 5 units. So our y-intercept is 5. So put a point on the y-intercept. And then our slope is just 1, 1. And connect your dots. So that's a translation up. Okay, we're going to go ahead and glue this in the next page in your journal. And then we'll do a worksheet in class tomorrow instead of having it as homework.